What's up, guys? So today we are keeping solve the GRE Physics. So I plan to solve these 5 questions in the video. So the number 60 is the Compton effect. And this formula is famous, so you need to remember it. You don't have time to solve to prove this formula. Because you don't have enough time. So you need to remember the answer. Okay, so this answer is A. So when I solve this review the test, I already remember the answer. So basically, you can go to Google Compton effect. I will leave the Wikipedia link below that. There's a they changed the diagram. Yeah, right there you can. There's a proof for this. Basically, you use the special relativity and momentum and energy conservation so that you can prove this. So number 60, you need to remember. Okay, number 61 asks about the excited state of helium and how to determine this, basically on which kind of principle. This is also like the physics common sense that since you have 2 electrons, so the spin 1, the total spin 1 states and the total spin 0 states. You have 2 kind of states. Basically, it is just the direct sum of the 2 spin half electrons. So this is the singlet. So why singlet is the ground state? This is basically use the Pauli exclusion principle. So 61 is just a common sense. Okay, 62. He asks about their VR to this and ask you about how many state of energy, 7/2 h bar omega. And basically, you can see that this is just the 3-dimensional harmonic oscillators. If you write down this Laplacian into the derived, you can see that the partial x and the x part, partial y and partial z part are all independent of each other. So basically, this is the single harmonic oscillator energy spectrum. So the total is nx, ny, and z plus 3/2 h bar omega is equal to 7/2 h bar omega. So this gives you that nx plus ny plus nz is equal to 2. And the nx need to be larger or greater than 0. So all we need to solve is how many ny plus nz, nx plus ny and z equals to 2. And the larger than 0, how many of them? So basically, you can count it. There are 6 of them. So we choose D. Okay. 63 is also the common sense that you need to remember. So the angular momentum has this kind of commutation relation, and the j square and jz are commute with each other. J square will commute with all the jx, jy, jz. So this is all you need to remember. So the answer is A. If you don't remember this, then you need to prove it. For example, jx, jy is not 0 because jx, jy is IH or IH bar jz, and the jx, jz is IH bar, jx, jz is minus IH bar jy. And the E choice that you know that the jx, jz will produce jy and jy, jz will produce jx. So definitely non-zero. Okay. So you say there's a cable elevator sending the elevator moving downwards through the shaft, the emergency brakes the elevator, stop the elevator shortly before it reaches the button. So when it reaches button, there's no velocity from and the height is 100 meter. So ask about how many heats that brakes must dissipate to bring the elevator safely to rest. So to rest is important. So the initial energy, the kinetic energy is 0, and the gravitational potential is 100 times 10 times 100. So this is mass times gravitational acceleration and times height, and this should be kind of heat. Oh no, it's too fast. So the total energy minus heat will become the total kinetic energy. So and the final state is rest, and the gravitational potential is 0. If I define this is 0, so that the heat is just equal to the gravitational potential. So it's 1 and 6 0. So it's 1 0 0 0 0 0 0. So the answer is E. So the answer is E. That's it.